I think people maybe not always realize how long it takes to manufacture, to produce one chip. And indeed, it takes up to 6 months because there is a lot of manufacturing steps. And this complexity of our industry, of course, meets external factors that influence the success of our industry. For example, export control restrictions, or access to energy, access to water, and so forth and so on. So we get to a point where we need a legal frame and a set, and we were very glad, very happy that the European legislator and the authority recognized this need and implemented it as fast as possible with the European Chips Act.
Riccardo, you're also representing the industry side of things. Give us your overview on why we are. I mean, I'm sure you have a lot in common in the comments, but Intel and Infineon are different. So tell us your perspective.
Thanks a lot, Jen. Indeed, Aude and I worked a lot over the past months on the EU Chips Act. I'm part of the government affairs team at Intel, and I coordinated all the advocacy work on the EU Chips Act. Why are we here now is because probably over the past few years, it was very apparent that there was an increase in demand of semiconductors, at the same time a decrease in production in Europe that has been the result of some business decisions over the past 30 years. And at the same time, the third factor is an increasing reliance and dependency on other regions, especially Asia. Europe has passed from 44% of global production in the 90s to roughly 8% today. And so policymakers realized that it's time to reshore, bring back some manufacturing, semiconductor manufacturing in Europe. And this is one of the key drivers of the EU Chips Act. Therefore, this acknowledgement brought also a different approach, which is a public-private partnership to make sure that there is enough public support by member states to make sure that companies can operate in Europe and be competitive vis-à-vis other regions of the world that have offered for over 30 years a number of incentives and favorable conditions for semiconductor companies to operate.
Samira, you're looking at quantum tech, and we talk about supply issues, but there's no supply issues without demand issues. So tell us a bit about that from your perspective.
I can just follow up on what Riccardo mentioned about the strategic issues that we have faced in the last, let's say, few years. It became more obvious. One of the main things that I just first addressed the CHIPS Act and then more for quantum perspective. The thing is, as you mentioned, we relied a lot on the suppliers in other parts of the world, especially in Asia. And now we see that there are a lot of geopolitical issues happening, and also there are a lot of crises for critical raw material, for energy, for experts. We have a lot of talent in Europe that they go somewhere else, mainly to US, because of higher salaries, because of better conditions. And this is why we ended up in a situation that we are now today, that, okay, where is the leading role of Europe in the semiconductor industry? So, and of course, we are going through this digital era. More and more digital aspects are happening in our lives. We have smart cities, we have IoT, we have autonomous driving, we have all these new medical devices. All these need kind of semiconductor chip in them. So there is more and more demand, for sure, and there is lack of production, and also there are some big gaps in like finalizing some devices because of lack of talent. For quantum as well, it's the same. I mean, we are going through this big transition. Quantum technology is soon to be a quantum industry. So there is also a high demand for quantum chips. And this is actually a part of the CHIPS Act as well that they're trying to tackle, because there will be more and more demand for many different quantum applications. It can be quantum computers, sensors, communication. So there is also very much a topic of security related to that, because these technologies are very prone to being hacked or being misused. So there is a lot of issues that we have to tackle, and of course there is a lot of demand.
Isabel, responsible electronics. I'm assuming this is about sustainability. This is about not just throwing things away as soon as we feel that we want the newest, shiniest thing. Am I right?
Yes and no, yeah. Okay. So, yeah, I think we need to mention that the EIC works with very fundamental research. So in that sense, responsible electronics means really looking for disruptive technologies in electronics, especially in semiconductors. And in my case, very much focused to suddenly, now it's back. So yeah, very much focused to sustainability issues, so really avoiding the use of critical raw materials, really, or less abundant, really breakthrough changes in the semiconductor supply chain. So it's not only about what we can do up to now in terms of more incremental sustainability in the factories, greening the companies, which is also very important, but also in how can we do semiconductors completely in a radical way. So yes, also the part of, we don't want to throw it away, we want to have some kind of easy recyclability, easy repairability, all those things are involved in the more fundamental research of semiconductors, and that's what we are looking for.
Well, Aude, let me come back to you. What are the measures we need to take to get this in-depth understanding of the issues in the global semiconductor supply chain? What do we need to be thinking about here at European level?
Yeah, let me first stress that it's very important to all stakeholders to get this deep understanding, whether the industry, of course, the authority, but also the consumers, because it all has, in the end, an impact on them and on the market. So understanding it and being able to evaluate how reliable our European chip supply is crucial. It is crucial, and I already mentioned the external and more or less complex and volatile parameters that must be taken into consideration and will, at some point in time and also at some point in the supply chain, influence or change the result of such analysis, export control, access to resources, energy, but also implementation of national and foreign regulation. So it's a real challenge. It's a real challenge to map this long and complex supply chain, but it's also very important. And I think actually Pillar 3 of the European Chips Act is not a surprise, and the crisis and monitoring mechanism actually paved the way for such analysis. It paved the way. It's a solid and good basis we should work on and start the work. However, I would like to keep in mind that gathering information is a very important first step, but in my eyes, not the decisive one. To me, the key to success will be really our ability to interpret the collected data correctly. And for that, we will need the expertise of the industry. This is, in my eyes, something that is maybe underdeveloped still in the CHIPS Act and in the implementation, and could greatly contribute to getting this deep understanding of our global supply chains.
Riccardo, I'm sure you're going to echo again quite a bit of what Aude said in relation to that. So, I mean, tell me about the measures, again, that you see should be taken. But I also want you to talk a little bit then about how we address a skills shortage.
All in the same answer? So, definitely the collaboration within the European ecosystem and information sharing that Aude was referring to is really important. If I had to pick one measure, would be international cooperation with like-minded countries. Because as you said, Jen, the supply chain is global. The supply chain is global because over the years, the high costs of this of this sector, the technology complexity led to specialization and consolidation across the global market, which means that today supply chains are global. The shift that we have seen over the past few years is that supply chains that were designed to deliver products just in time and to be cost effective now have to be resilient and adapt to unforeseen events. And so they have to be ready just in case something happens. And so together with the global supply chains, now we need to reinforce the regional supply chains. Regional supply chains won't be autonomous, won't be independent, won't be self-sufficient. For this reason, we need to be always in an open dialogue, continuous dialogue with like-minded countries. The European Union is doing this with Japan, has started also a Tech and Trade Council with India, but probably, and here I represent a US company that has operated in Europe over 30 years, the EU-US Trade and Tech Council is an excellent platform for collaboration on semiconductor policy issues. There is a specific working group, there is a specific subgroup working on semiconductors, and the coordination can happen at different levels. Can happen on early warning systems, information sharing, but it can happen also in trying to make let's say the incentives and the public support more coordinated between partners in a way that there's not a race to the bottom, as the declaration from last week of the TTC mentioned explicitly. The EU and the US are committed not to have a race to the bottom for public support. Since we are talking about responsible manufacturing, etc., an interesting area of collaboration worldwide is R&D on PFAS and persistent chemical substances. Those are challenges that the global supply chain needs to address, and therefore increased collaboration with like-minded countries is the way to go.
Moving to the skills question, Samira, have we a skills shortage? I mean, if you look around the EIT conferences, not just EIT Digital, but raw materials a couple of weeks ago, there seem to be a lot of very skilled people here, but that doesn't seem to be translating to what you read in the headlines and what we hear as problems.
We definitely have a lot of talent in Europe, and we are a producer of talent for most part of the world. That's the problem, I think. Well, there is the issue is these technologies, like for instance, quantum technology is very complex. So you usually need people at the level of PhD who are running these devices, at least for now, that we don't have these amazing software controls that can identify the bug immediately. So you constantly have like 3 highly educated people monitoring a tool working. I lost it. This is very demanding. So this is where it happens that we are losing the talent, or we are losing the number of talent that we need, because many of them are attracted to, well, let's say, better lifestyle, better salaries, and they move to US. I recently had a discussion with a US company, and they were saying, I don't know what's happening.
Persevere.
They were saying that, I don't know.
No.
You can hear me. It's just going away. That they open thing. Can you hear me now? Yeah. So they open a branch in Europe where there is a good university, so they can immediately give an offer to the graduates and take them. They work in Europe, but they work for US. So he told me they have $6 billion revenue each year because of the European talent. So you see, there is an issue. They might stay in Europe, but they work for the benefit of someone else in another part of the world. So we have to look into that very deeply. First of all, we have to definitely work with the member states to have more dedicated and focused programs for the technologies that are going to boom in the coming years, semiconductor, quantum technologies, because we need more and more talent, because more of our life will be digitalized. But at the same time, we have to be able to, we can't, as it was mentioned, semiconductor is difficult. So you can't expect that a graduate will come to the company and revolutionize everything. You need people who have 20, 30 years of expertise to do proper work if you want to start a new fabrication or foundry in Europe. So we need to attract the talent also, like kind of come home or package offers to attract them to come back to Europe again and help us building these new foundries and these new, let's say, production lines that we are looking for.
Riccardo, European talent working for American companies. I don't know if that rings any bells for you.
Well, definitely, we have operated in Europe for over 30 years in Ireland, and soon, hopefully, we announced a plant also in Germany. This means that Europe has talent for the semiconductor sector. Now, if we're talking about attracting talent, as Samira was referring to, it's a very complex activity in the sense that talent, like the supply chain, is global, and so to attract the best caliber of talent, you need also to offer an interesting package that goes from housing, international schooling, medical services to streamlined visas. You need potentially also tax credits and other forms of incentives that would bring more people to Europe. Now, if you're looking at creating this talent in Europe, it's very important to create the talent at the PhD level. But in addition to what Samira said, we need also a lot of technicians to run the fabs. On the Ford plant, there are a number of technicians that don't need a PhD degree, but they need high school or applied science schools degrees. And those are essential for the functioning and the operation. So it's a mix of skills creation, creating the right curricula at high school and university level. It's a mix of upskilling. Europe has a lot of manufacturing activities, but those workers are don't have all the skills for a sector that is so technologically complex, like the semiconductor sector. And we need also reskilling, because there are a lot of workers that are not at all into the manufacturing activities. All these activities, skills creation, upskilling, reskilling, so far has been done mainly by the industry sector, right? The biggest shift now, the paradigm shift, would be that now industry and government work together to create, all those paths and the opportunities for developing talent or upskilling, reskilling talent that is already in Europe.
Oh, do you wanted to have a quick jump in as well?
Yeah, quick job, thank you very much. You started your question with the market, and indeed, let me confirm that the market is very tense and also very competitive, not only within the European Union, but also globally. We are competing globally to fill open position in the semiconductor industry. So it's also due to the fact that we are very dynamic and developing emerging technology requiring new skills that are not yet in the market and maybe also not yet in the university. And also, and it's a fairly simple calculation, I think that situation is not going to improve, because with the happy announcement of opening of new fabs in Europe, of course, there will be a new position to be filled. So we definitely need to attract, but also to retain talents in the European Unions and in our semiconductor companies. And we raised the point of raising awareness, which is, in my opinion, a fundamental point, because we are business-to-business industry. So I'm not sure actually young generation or the wide public knows how semiconductor contribute to green transition, digitalization, decarbonization, and this is something in which they could find a higher purpose, you know, and a sincere motivation to join us. And this point is important, and it has been, in my eyes, already recognized by the authority and the industry, because I think we should look back at what is ongoing or what has been done. And here I would like to mention maybe the work of allpro.eu, which is a project funded by the European Commission under the Digital Europe program, and especially their campaign to encourage women embracing technical careers, technical fields. And I would like also to mention another one, which is the METIS project, which is the consortium of 20 partners representing the industry, and that's really made it to map the market needs in the next years. So yeah, that's very important.
Isabel, I was coming to you next. I was going to ask you about semiconductor competence centers, but if you want to react first.
What did we do? So now it's better, no? Yeah. So yeah, I wanted to continue with this international cooperation and where we are. I wanted to be a little bit more positive also in the European side. So I think we can build on the strengths that we have in Europe, that we have some. And also talking about let's say the verticals, we are very good at the automotive, let's say mobility sector. We are very good at the industry sector. So maybe we can build this international cooperation based on our strengths also. And maybe we could be helped by the others on other sectors like consumer, which of course Europe is not good at all, but we have strengths that we should build on those. Also in terms of coming back to sustainability, Europe is like the most concerned and the continent that is really looking for these kind of solutions, and we are at the first level, so we should build also on those. And I think that's very important also, that we are able to make sure that we are strong in some of our verticals, and we should keep on those.
Well, let me turn to what I do want you to tell us a bit more about, which is the semiconductor competence centers. What sort of strategies are they implementing? Explain to us, for those who don't know, what they're doing, and how is the interaction between the competence centers and startups or SMEs? How does that work?
So first of all, I wanted to say that I am not from DG Connect. I work for the European Innovation Council, so it's really the connection with the startups on the SMEs. So yeah, the competence centers, maybe Samira can explain better than me this part. I can already say that as EIC, what we are trying to do is to help, as I said, this journey from the very fundamental research, in this case in semiconductors, all the way to the exploitation for the startups. And yes, we are also working in how can we somehow look for these novel startups that could make a difference in Europe. That's mainly our role in the semiconductor field. And also we would like to benefit from these competence centers that are being created, and also the design platforms and all the tailored different initiatives that the CHIPS Act, because we would like to really put together and liaise our companies, our startups, with where the prototyping can be done, the pilot lines, where the design centers will be, or the libraries will be, and all those will help our companies very much in really achieving the goals of the European Innovation Council. But what comes from the competence center, maybe Samira, you know better than me where we are now.
I can say a few words. I think you explained it very well, but the thing is, the competence center, the idea is like the big RTOs that we have in Europe, like IMEC, Fraunhofer, VTT, and so on. They will, because they are very advanced in technology, they have a lot of skills in-house. we will try to use what they have to improve the whole ecosystem in the at the European scale. So these centers will have some mandates, of course, to for instance, provide test beds, benchmarking, and pilot lines for startups, for smaller, for companies and SMEs to have access and to improve their products and to help them basically to jump this bottleneck that most of them are facing when they have a prototype and they want to go to scale up. So this is a way to push the innovation in Europe to go closer to the market. Also, the pilot lines, the design platforms that Isabel mentioned are also a way to make some steps easier for the startups. For instance, not every startup has the budget or the time to go through a CMOS design for their own product. It can be a design platform that they can go, it's like pick and place. They just select this specific CMOS and match it for the product they want to, a device that they want to build up on top of that. So these kind of things are going to facilitate basically the semiconductor movement in Europe and help the players to be a bit faster and have a little bit, let's say, more support from the ecosystem instead of struggling and knocking the doors without really getting response.
Thank you. I think that's been quite a good grounding, despite you saying you don't want to take ownership of something that's based in DG Connect. Riccardo, let's talk about a lot of the benchmarks and the targets that we've seen and heard talked about. I mean, let's take one. So scaling up production capacity to 20% of the global market is that feasible? Are we on track? How do we put, is that something we can strive towards?
Thanks, Jen. This is an easy question. Well, the ambition is the right one. The CHIPS Act is setting the right priorities for the semiconductor industry in Europe to thrive. More research, more investments in manufacturing, both front end and back end. More investments across all the segments, and increased collaboration across the ecosystem. So, as I was saying earlier, Europe was in the position of being the top producer of semiconductors 30 years ago. There were different market conditions. There were also different industry players in Europe. Now, going from the 8%, the current 8% to 20% is certainly a very ambitious goal. But this can be done in the future by focusing on manufacturing, but at the same time trying to grow also the other segments that make the supply chain. And so design, fab equipment, manufacturing, all contribute to boost the semiconductor ecosystem.
Aude, well, go ahead, yes.
Thank you. Yes, I support all Riccardo said. I think the target is indeed ambitious, but achievable. And I think as soon as the European CHIPS Act is passed and is valid, we will have all bytes and pieces in our hands to reach these targets. And indeed, with the press announcement for the opening of new manufacturing sites, for example, Infineon in Dresden, ST Microelectronic in France, in Italy, and Riccardo said also Intel in Germany, we clearly see that the implementation of the CHIPS Act has already started. And in my eyes, our success and the key to reach our targets will depend on our ability to rapidly and effectively implement the tools and measures defined in the CHIPS Act. So it's really important that we start early, because you can imagine you cannot build a manufacturing site overnight, because we're not China. It's maybe possible in China, but not here. So it takes time, and it's important that we can go through all the administrative procedures and approvals swiftly and efficiently to be able to start implement it and start competing.
Well, Isabel, to come back to the R&D side of things, I mean, that's obviously essential. How do we get the right sort of R&D leadership in Europe? You know, we want faster, smaller, all singing, all dancing chips. Is the research side on the right track? I mean, we've talked about manufacturing, we've talked about scale-up. What about the research?
Well, as I think it was mentioned already at the beginning, we are very good at R&D. So let's say that if you look at any numbers, patents, articles, everything, we are like Europe is at the forefront. So our difficulty is how do we translate this into exploitation? How do we bring this really to the market? And that's where we are struggling. The EIC was created for that, but many other initiatives. I think also the EIT is really working hard on that. So that's where we have to work. And of course, keeping research and being able to continue with this research. But we're struggling to make that happen. No? So yes, of course, we need research because we are very good and we need to continue. As I said, we need to continue working on our strengths, and that's one of our strengths. But we also need to put in place all the measures available to make things exploitable, to help the companies, entrepreneurship kind of mindset. There are many things that need to be changed in Europe so that all this research finally goes to exploitation. And probably research won't be the most difficult one.
Samira, final question to you. The same thing. Are we on the right track from an R&D perspective? Where do you identify any gaps that we need to fill? Because we've been talking about this for a long time. I remember Neelie Kroes saying we needed to build an Airbus for chips. I'm showing my age now, but that was several years ago. What do we need to get right, and what do we need to get right fast?
I totally agree with Isabel that we are doing very well in research. I think this is nothing new that we have. I think our Mrs. Mother Lion also said that we are very good to put money to do research, but we are not so good to make money out of research. That's the problem. So we have a lot of good talent. We have a lot of good deep research. I mean, for instance, quantum mechanics was built in Europe, but now you can see that many things are happening faster in the US. One thing that I really think we have to change is this mindset of investment. We need more patient private investment in deep tech. We need the investors to understand that semiconductors, quantum technologies, they are very complicated, difficult, time-consuming, expensive technologies, but they are necessary. And this is every country or continent that has its let's say, first and fast in the best way rolling, will have a lot of advantages. So this is very important to push a little bit more for helping these startups that are very knowledgeable. They have a lot of great ideas to really reach to the market and really push past this barrier that is stopping them. I think we have definitely no problem for science and research, but there is a big gap for helping these scientists and these startups to reach to the market.
Riccardo.
Indeed. So the comment is that clearly Europe is great in R&D, and the examples of IMEC from Ofer, Cealeti, but there are many other research centers on semiconductors in other member states. Now the challenge is that the EU-Chips Act now is boosting a number of investments, and we're trying to fill the gap from between lab and fab, between what is R&D pathfinding to concrete industrial development of technologies. The big challenge that I see going forward, and back to the ambitious objectives of 20% and beyond, is that the CHIPS Act is creating now favorable conditions for attracting investments in Europe, especially in manufacturing. the challenge is maintaining this competitiveness and this attractiveness in the long term for Europe, and making sure that those investments will continue flowing into Europe going forward. So it's not just a short-term game, but actually the real game is long-term. And this is where we all need policymakers and industry to see how to maintain this competitiveness. Public support now is helpful because companies like ours are investing more in Europe, but we will need to see in the long term how this applies. Last point, the concept of first-of-a-kind facilities, that is one of the novelties introduced by the CHIPS Act, really emphasizes the importance of allocating wisely public resources to innovative projects. But innovative projects are not just leading-edge chips that we produce, for instance, but the concept that has brought the CHIPS Act is that there's innovation across process and products and across different technologies. And so this is a way also to attract more investments in Europe and trying to win the challenge that I was referring earlier.
Aude, you're going to have the final word of the panel. Where do you see the gaps? Give us our takeaway that we should all be thinking about when it comes to semiconductor supply chains.
Well, thank you for the honor of holding the panel. Indeed, a very important question. I think we raised most of the point. If I may allow to sum up what has been said, one big point is the skills market that we raised already, but also the fact that we need to reinforce our strengths to stay leaders in the fields we are leaders, and fill the gap in design, continue research and development, and be fast and efficient in implementing all the measures that we may think appropriate to do so. So to me, it's key.
Well, thank you very much. Can we have a round of applause for all our great panelists? Thank you.